Assalamualaikum and very good morning, doctor and my fellow friend. Today I'll be talking about the thermogravimetric analysis or TGA. The main purpose of TGA is a measure weight change in material they are heated, cooled or kept at consistent temperature. By doing this, TGA provides valuable information about the thermal stability and composition of this material. Now, let's look at how TGA works. First, a sample is exposed to a controlled temperature program. As the temperature changes, the mass of the sample is continuously recorded. Various processes like oxidation, reduction, dehydration, and decomposition can affect the sample weight. The weight change are displayed as a thermogravimetric curve or TG curve and a derivative curve, known as the DTG curve, which provide more detailed information on the rate of weight change. So TGA has a wide range of application across different industries. In the polymer industry, TGA helps determine the composition and thermal stability of polymer blend and composite. In the pharmaceutical field, it is used to assess the stability and purity of active substance. In material science, TGA study the thermal decomposition and reaction kinetic of inorganic material. Overall, TGA is essential for quality control and the development of new material with specific thermal property. Thermogravimetric analysis is a crucial technique for understanding the thermal behavior of material. Inability to measure weight change under controlled temperature conditions make it indispensable for various industry research applications. So we move to next slide is method. First, let's discuss simple preparation process. Start by weighing about 5 to 20 mg of sample material. This sample is then placed in a clean, dry crucible. It's crucial to accurately record the initial weight of the sample to ensure precise measurement. Next, we move on to the instrument setup. We switch on the TGA instrument and allow it to equilibrate. The TGA analysis software is set up on the connected computer. If needed, we calibrate the TGA instrument according to the manufacturer instruction to ensure accurate result. Now, let's define the experimental condition. We set the temperature range for the test, which typically run from room temperature to 1800 degrees Celsius. The heating rate is usually set to 10 degrees Celsius per minute. Although this can vary depending on the material of specific analysis requirement. For this experiment, we'll use nitrogen to ensure an inert atmosphere. To carry out the experiment, we place the crucible containing the sample on the balance pan inside the furnace of the TGA instrument. We then close the furnace and begin the analysis. As the temperature increases, we monitor the weight change of the sample. The results are recorded as the thermogravimetric curve, TG curve. showing weight versus temperature, and the derivative thermogravimetric curve (BTG curve) showing the rate of weight change versus temperature. After the experiment, we analyzed the data from the TG and DTG curve. We identify key thermal events such as the one set of decomposition, peak decomposition temperature, and residual weight. This weight change help us determine the thermal stability and composition of the sample. We can then compare our result with knowing standard or literature value to interpret the material thermal behavior. Finally, we move on to post-experiment procedure. We allow the TGA instrument to cool down before removing the sample. The crucible are cleaned thoroughly for the future use. The collected data is analyzed using the TGS software, saved for future interpretation, and used to prepare a detailed report. So we move to next slide is result. In our thermogravimetric analysis TGA of the sample, we observe two distinct stages of combustion or decomposition. First stage is the sample experiences a weight loss of 25.06%, which is equivalent to 3.71 mg. This stage occurred within the temperature range of 36.66 degrees Celsius to 350.52 degrees Celsius. The heating rate was maintained at 15.00 degrees Celsius per minute. The inflection point with the most significant change the observed was at 284.51 degrees Celsius, and the midpoint of this change was at 285.27 degrees Celsius. No residue was detected after this stage. For the second stage is the sample showed a more significant weight loss of 74.60%, equivalent to 11.04 mg. This stage took place between 350.53 degrees Celsius and 791.75 degrees Celsius. The heating rate remained consistent at 15.00 degrees Celsius per minute. The inflection point for this stage was at 430.06 degrees Celsius, and the midpoint was at 422.96 degrees Celsius. A small residue of 0.34% was found after this stage. This observation highlights the thermal stability and decomposition characteristics of the sample, providing valuable insight into its behavior under controlled temperature conditions.
Okay, technique step in a TGA experiment. Initial weight measurement. The initial mass of the sample is recorded. Heating or cooling. The sample is heat or cooled according to the preset program. Mass recording. The mass of the sample is recorded continuously throughout the process. And the last one, data interpretation. The data is plotted as a thermogram, mass versus temperature or time. Analysis of the thermogram reveal critical thermal properties of the material. Next is a discussion. The result of thermographic metric. analysis, or known as TGA, can be achieved in an accurate and fast way through a smooth workflow. TGA is also analytical technique used to convert the mass change of a substance into a fun, fun, sorry, function of temperature or time under a controlled atmosphere. Accurate results are delivered by the TGA instrument using our renowned ultra microbalance with a sub-microgram resolution over the entire measurement range. The name of the machine used is a simultaneous thermogravimetry and differential scanning calorimetry analyzer. This machine uses the help of nitrogen or oxygen gas and also uh, produce both. The one the one-click function found of the color touch screen display is used to perform common measurement in a easy, safe and fast way. A barcode reader is used to identify the sample. Okay, the last one is a conclusion. In conclusion, TGA is an important analytical technique that is widely used in various fields such as material science and chemistry. This technique provides good insight and result in terms of stability, composition, and decomposition of material by varying the mass change as a function of temperature or time under a controlled atmosphere. This can be seen in terms um, of turn stability. TGA play a important role in determining the thermal stability of material. By monitoring and observing the weight loss as the temperature increase, we can identify the temperature at which the decomposition, oxidation, or other term event occur. This is important for application where the material is exposed to high temperature. That's all for me. Thank you.